a USB-powered nocturnal poop illuminator. I've already featured one of these, but it was powered by three AAA cells. But this one is USB rechargeable. And if you see the LED in this, looks like it's shimmering and flickering and strobing between colours. It's simply the pulse width modulation. It uses pulse width modulation, the on-to-off ratio of each of the three chips, red, green, blue, to vary the colour. And the camera is picking that up. It's not really visible to the naked eye, and even when I shake it, it's not too stroby. So this thing came from eBay rather predictably. It wasn't that expensive. I should actually have gone and got the listing. Hold on, I'm going to go and get the listing one moment. Here we go. The description is 8-colour LED body sensing motion sensor night lamp toilet lighting USB charging. Just a string of keywords. You'll find these easily. I paid $6.28 or thereabouts for it. They're cheap. You know, it's quite nice just to buy as a sort of general gimmick. It's got other uses, I suppose. The instructions make for very interesting reading because they're clearly not aimed at this model. They're aimed at the original one with the batteries. And it says, Instructions 1. Fit to toilet. Adjust length of arm right size. 2. Install light bowl. Insert batteries right size arm to hang light bowl on the rim of the toilet. Turn out the lights. Light bowl only works in the body sensor when it detects movement. It will turn on and stay on for 30 minutes. It does not after last movement. If the lights are on, the light bulb will stay off, saving the batteries for when you need them most. Right, okay, let's correct that. This unit has a passive infrared detector. It does not have a light sensor. It will turn on at any time of day when it detects any movement in the vicinity. And it runs for about 2 minutes and then it shuts back off again when it doesn't detect movement. 4. Set a colour or let them rotate. Set the button to the out position to cycle colours. Press the button in to set a single colour when desired colour is visible. Okay, I played about with this. It did not comply with the instructions. You have a button here, a clicky button. If you press and hold the button, the LED goes out. If you press and hold it in again, it flashes 3 times, and then when it detects movement, it starts gradually cycling through the colours. At any time, if you've got a preferred colour that you like to view your poop in, say for instance you like a turquoise colour, or in this case a nice orange colour, you can click the button at that point and it will hold that nice orange colour so your poop has colorific consistency in the future. Excellent. Charge. Please turn off the lights before charge. USB input DC, 5 volts, 500 milliamps. It's a standard micro USB charging port on the side, covered in a flap. Let's call it a piss flap. It literally is a piss flap and a shit flap as well. Charging show red for about half an hour, and you can see LED shining through this fascia. Hold on, do I have a USB power bank? Yes, I do. I have a large. Actually, I'll go for my usual pink USB power bank. Here we go. Let's plug this into charge and plug it into the side. It's one of those little tiny flaps that's quite hard to open. I'm going to open this. Rest assured, I will get round to opening it shortly, and we'll analyse the circuitry. So you plug it in, red LED lights, and once it's charged, that does change to a green LED under this. It's quite nice. It's a nice translucent cover. So that works. It then goes on to say, Manuel. 3 modes, press the button for 3 seconds, 8 colours will be anatomically changed. It will last for about 120 seconds. Press the button for 1 time, single colour will be stayed. The same as you press the button, click the button, aging, 8 colours will be chagged gradually again. Lights will be switched off according to pressing the button for 3 seconds. Yes, okay, that's convincing. So in reality, what you do is you hook this over your toilet rim. It makes sure piss and shit and everything, no matter the time of day, but more visible at night. It makes the toilet bowl glow in a lovely colour of your choosing by using that pause button. And then when it comes to the point that it's actually so dim you can't see your shit or urine anymore, you get your marigold on. And you gently unstick this from the rim which it will be congealed onto. And you get a mustard spoon, and you use the mustard spoon to scrape all the congealed feces off the side of the unit and the urinary spatter. And then you can also use the mustard spoon to then prise it open before stuffing in your USB charger and placing the congealed sticky unit onto a piece of toilet paper to charge from your phone charger. Excellent. So very straightforward and easy to use. Let's open it up. Gloves off. So here we go. It's got 3 screws. 1, 2, and 3. I wonder what size of battery it's going to have in here. I'll open this flap. I've noticed that in some of these units, if you try just pulling them open, as this one does, oh, the button's pinged out. Oh, that's not bad. You can just open it, but I have noticed in some of these units you have to be careful to pull the flap back, because otherwise it sort of puts resistance in this. So what do we have here? We've got a little lithium cell at the bottom here, which is stuck in. It doesn't seem to have any protection circuitry in the lithium cell itself. Let's get in closer to this, but not too close. We've got the button here. Little transistor down there. There's the LEDs. We've got the passive infrared detector module. Fairly standard little clip-on module over the piezoelectric sensor. Let's go in a bit further. I can see it's not, that makes sense, it's not just a standard colour changing LED, it's actually got 1, 2, 3, 4 wires going down, which is probably common red, green and blue. And it'll have the ubiquitous 8-pin microcontroller probably controlling that. And a little passive, probably BIS 0001. Passive infrared detector. No, it's not. This merits further investigation. It's got a chip with a number on it. What is the number on that chip? AS092. That's probably the charge controlling chip. You know what, I'm going to take a picture of this and then we'll take a closer look at it in greater detail. I'll also see if I can find out what these chips are, so I'll be back in a moment. Slightly more than a moment later, I have reverse engineered this and there are some components we'll take a look at after that are really odd. Well, that one, and that one namely. Okay. But before we do that, let's take a look at the top of the circuit board, which has the button, which is straightforward enough. It's got a transistor, it's got the 2 LEDs and one common 471, 4710, 470 ohm resistor to limit the current through the charge indicator LEDs. In this case, the transistor has just been used from a simple line from the charging control chip. It's been used to switch between the 2 colours. This bit here, the passive infrared detector, there's a lot of science in this. It must be so much more expensive to make these than the modern microwave detectors, but ultimately it's got a very, very low quiescent current consumption. The technology involves this thermoelectric sensor, which detects body heat, it detects long-wave infrared, and it generates a very slight voltage. But there's 2 sections. And if you look at the lens in these, you'll see that it's a patterned polyethylene lens. Now, the polyethylene or polyethylene lens is chosen because it passes the long-wave infrared. If you were to use a glass lens, it would block the infrared. Many plastics do block that wavelength of infrared, as demonstrated by thermal imaging cameras. But it's got a series of lenses, and what they do is they create moving hotspots. When you walk about in front of the unit, it creates a sort of hotspot that moves across it. So the ambient infrared heat, the ambient room emission, stimulates both the positive and the negative ones. They're configured back to back to do that. But when you get a point source of heat moving about in front of these lenses, it creates a pattern, a sort of spike of heat that passes over. And when it does that, it causes a push-pull effect, and that then drives a MOSFET in here, well, a FET, a field effect transistor, very sensitive transistor, that then creates a fluctuating voltage when it detects movement in the room. Very simple in a way, but actually really complex. These bits used to cost a fortune. Now, of course, they're just willy-nilly. They're just cheap because they're used in everything. That's the thing about mass production. Then it all gets a bit interesting. I couldn't identify this chip, but I've worked out it's a voltage regulator. I couldn't identify this chip, but I think it's battery protection. This one here is, let's move in a little bit. Let's get a little bit closer to the action. So this one here marked LTH7. That's, is it a 4054? That is a generic lithium charger. What it does is it takes a supply in from the USB port, and it's got decoupling capacitors, usually a high value and a low value one, just to provide good filtering. The chip itself, and then it's got one resistor locally that sets the charge current, and by varying that resistor value, you set the current maximum current it's going to charge the cell with. So for instance, if you're using this to charge an 18650, you could set it up to 500 milliamps or higher. But for something like this, it may be set for a lower current, just maybe a couple of hundred milliamps. They do allude to 500 milliamps in the manual. I wonder if this is a 500 milliamp hour cell. Not sure. I don't think it's that high a capacity, but then it doesn't need to be. So that covers that. This I drew a blank on completely. If we get the meter in, let's bring in the meter here. The Fluke at the moment, with its slightly overshadowed display. And we set it to the voltage setting, and I probe on that chip. Then it's connected to the negative pole, which is pretty common for this type of chip. It's got the classic filter that you'd expect of a DW01 chip. I'll show you what I'm probing here. This is the negative connection of the lithium cells. This is coming from the positive I've already deduced from the positive lithium cell. It's pretty much, if I put this between the positive and the top of that resistor, there's virtually no difference in voltage being shown. If I put it to the negative and then go there, it's showing the full lithium cell voltage, which at this point in time is approximately 4 volts. So it's got the lithium cell voltage, the positive voltage, coming through this resistor to a capacitor, and the reason it's doing that is so that as the load fluctuates up and down, it doesn't cause this to trip out accidentally. It's sort of filtering. And I'm guessing then that this is just a very simple device that once the voltage goes too low, or maybe even too high as well, it will actually break the connection. It's almost like a DW01 and the MOSFET combined into one little package. But as I say, I couldn't find that number. I did a good length of search. Sometimes my searches aren't that long. Sometimes they're lazy searches, but I think this one I spent a modest amount of time. Let's go on to the negative of the lithium cell here. Let's go up to this component here, which I think is a voltage regulator. I go to the connection here, which is showing a voltage of 3.98. So that's the lithium cell voltage, 3.99, near enough 4 volts. I go to this connection here. It's connected to ground, so 0 volts. And then I'm going to this connection here, and I'm getting 2.5 volts. So I reckon this is a 2.5 volt regulator. That makes sense. I should actually let's bring the meter in so you can actually see. Let's try that again. So on this one, I'm getting the battery voltage. On this one, I'm getting 0 volts. And on this one, I'm getting 2.5 volts. You see, I wish I'd done that. I wish I'd spotted that the meter was out of shot. That's the peril of me zooming in. Likewise, I can show you then, if you didn't see it before, that down in this little chip down here, if I go to this connection here, that is the plus volts from the lithium cell. So I'll bring that in. You can see that is the 4 volts that it's using to sample. It's using that resistor and that capacitor as a filter, and then it's just switching from the negative of the lithium cell to the negative of the general circuit. This chip is the intriguing bit. This is a very odd thing, because if you look up that chip number, you do find a data sheet, AS092. Here we go. Let's zoom out for this. AS092, it's made by AS chip. It seems appropriate for a toilet light. And you look at it, and it doesn't seem to show anything. It seems like it's a standard passive infrared detector chip. And if you look at the diagrams, there's no hint that it's controlling an RGB chip. And that's why I was thinking earlier on then. I was thinking, what's controlling the colour of the LED then? How are you actually controlling this as a switch? Particularly when the switch comes to this chip and then controlling the red, green and blue. So I looked down, and I was hoping to find more information about that. Loads of schematics showing this being used as solar garden lights and stuff like that. Nothing really revealing. All it just shows is a constant single output to a MOSFET here to switch on garden lights, or in this case it will drive the LED directly. But then I found another chip in the range called the AS090. And it does control RGB LEDs, but it doesn't seem to have the same pinout. So this looks like it's a chip that they've not really documented that combines. Another thing is this one, the input to this shows the passive infrared sensor with all this buffering and amplifying filtering circuitry around it before it goes into the actual unit. But in reality, there's very little between the passive infrared detector. It's basically a resistor and capacitor, and then it's going straight in, and the other side of that is just the supply voltage. So this chip is a non-standard one. It's not documented. It's combining the passive infrared detector with all the excess circuitry removed, and then ultimately it's just then driving the RGB LEDs directly. So that is very much just custom designed for this task. That button input, the lithium power supply, well, the 2.5 volt supply, and then switching the 3 LEDs with a common for the LEDs, and then a resistor per LED. Noting that there's a 0 ohm link here, and the other ones are 10 ohm. I'm guessing that might be the higher voltage LED, just to say, for instance, that could be green. Not sure. Doesn't help when they've just used black, red, and one of those will be the common connection. And the others will be the colours probably being pulled down to the negative. Or in this case, actually, no, because this, oh no, I thought that was going straight up to that, but it's not. Not sure. Normally, they'd have the LEDs connected COM positive, and then it would be switching down to the negative rail, which makes sense because the positive rail to this one is the 2.5 volts, and that wouldn't be high enough for the LEDs. So it's an interesting little unit. Once again, it's a marvel of science being used for an absolutely flippant task of illuminating your poo. But then that's science for you. The metal frame here, incidentally, has an actual shaped steel insert here to give it extra rigidity so it grips onto your toilet tightly to ensure a good seal against all the urinary and pooperary secretions, so it gets a nice good contact with them. So yeah, interesting little device. It's quite smart, and well, it's certainly a novel enough toy just for its toy value.